Okay, let's solve the second problem. Here we are given such a function and we have a triangular region bounded by these lines. And first of all, again, we will start with step 1, finding critical points in D. Okay, so to do this, I will first of all calculate the first partial derivatives and then equate them to 0. I have 4x minus 4 as a first partial derivative with respect to x, and first partial derivative with respect to y is 2y minus 4. If you equate them to 0 from the first equation, I have x is 2, and from the second equation I have y is 2. Sorry, x is 1 and y is 2. So y2 is the only critical points of f of xy. And since this satisfies 1, 2 here, 1, 2 satisfies y equals 2x, it belongs to the given region. So we will put this point on our table at the final step. Okay, let's check the boundaries. Step 2, boundaries. To do this, first of all, we should obtain the given region. Okay, so I have x is 0, this is x is 0 line, and y is 2 line here, y is 2, and y is 2x. It is a line passing through 0, 0 and has slope 2. So when y is 2 here, to find this intersection point, if y is 2, then 2 equals 2x, so x is 1. So here the point 1, 2. And this is also the critical point we have found in the first step. So this is our region, okay? So as you can see, we have three boundaries, and the boundaries are, first of all, x is 0 line, and then y is 2 line, and at the end y is 2x line. Okay, so when x is 0, we have y between 0 and 2. When x is 2, y is 2, we have x is between 0 and 1. When y is 2x, again we have x is between 0 and 1. Just look at this part. When x is 2x, the boundary is that, and x changes between 0 and 1. When x is 0, boundary is here, right? And on this boundary, y changes between 0 and 2. When y is 2, we are on this line, so on this boundary, x changes between 0 and 1. Okay, so now let's continue with the analysis of those boundaries. So first of all, on L1, here on L1, we have x is 0, and as I said at the beginning, because of this here, here we have and let me write directly there, y changes between 0 and 2, and here x changes between 0 and 1, and here we still x changes between 0 and 1. Okay, so I have this 0 is less than or equal to y, and it is less than or equal to 2. So on this line, our function turns to, what is the function? 2x squared minus 4x plus y squared minus 4y plus 1. So I have f 0y here. So this is 0, this is 0. We have y squared minus 4y plus 1. Okay. So again, it is a little bit difficult to decide whether or not this is an increasing function, okay? So because of that, I will use the idea of single valued functions here. So I will define g of y like that. F of 0y which is y squared minus 4y plus 1. And because of that interval, we are on 0 and 2 intervals. So we have a single valued function and we have that interval. So to find the absolute minimum or absolute maximum of this function, first of all, I will calculate its critical point, 2y minus 4, to equate it to 0. I have y is 2. Okay, if y is 2 here, because x is 0, we have the point 0, 2. Okay, so this is critical points, and we have endpoints, right? Y is 0 and y is 2 are endpoints also. So as you can see, we have two different points. Okay, so I will write it here. If y is 2, at the beginning I have x is 0, 0, 2, and 0, 0 should be analyzed for this boundary. So this is critical points, this is endpoints. From the first boundary we have 2 points. Okay, so let's check the second boundary. On L2 we have y equals 2 and x changes between 0 and 1. Okay, so my function turns to 2x squared minus 4x plus y squared minus 4y plus 1. So I have f of x is a variable and y is 2 here. So 2x squared minus 4x plus 4 minus 16, sorry, not 16, 8 plus 1. So we have this 2x squared minus 4x minus 3. Okay. And x changes between 0 and 1. So I will define another function h of x, which is the f of x2. It is 2x squared minus 4x minus 3, and we are on this interval 0, 1. X changes between this interval. So we have two endpoints. And to find the critical point, I will evaluate the first derivative of this function and to equate it to 0. And so I have obtained x is 1 here, so one of the endpoints. So at the end, when x is 1, we have two different points here. X is 1 is critical points. Also, x is 0 and x is 1 are endpoints. So we should deal with the following points here. When x is 1, y is 2, and when x is 0, y is 2 again. So we have two different points from here also. And then we have the final boundary, which is L2 on L3. We have y is 2x and x is between 0 and 1. Okay, so I have f of xy equals 2x squared minus 4x plus y squared minus 4y plus 1. So it turns to f of x to x now, 2x squared minus 4x plus 2x full squared here. I just replace y with 2x minus 4 times 2x plus 1. So here I have 2x squared minus 4x plus 4x squared plus minus 8x plus 1. So the function turns to 6x squared minus 12x plus 1. Okay, so again, because we have single variable function and an interval, I will define another function k of x, which is 6x squared minus 12x plus 1. We know endpoints, so to find the critical point, I will evaluate the first derivative. 12x minus 12 equals 0, which is x is 1. Okay, so we have obtained the same endpoint. So this is critical point. I have x is 0 and x is 1 are endpoints. So which points we should deal with? when x is 1, for this time I should substitute it here. When x is 1, y is 2, and when x is 0, y is 0. Okay, so how many points we have? First of all, I have, where is the, yes, 1, 2, this is the critical point, okay? And let me write 1, 2 first of all. So step 3, charts. xy, f of xy. Okay, so 1, 2 here. First of all, we have obtained this. And from here we have 0, 2, and 0, 0. 0, 2, and 0, 0. And in the second boundary, we have 1, 2, and 0, 0. 1, 2 is here, and 0, 2 is here. And at the end, I have 1, 2, and 0, 0, 1, 2 is here, and 0, 0 is here. So I will calculate my function at these points to decide the absolute minimum and the absolute maximum. So let's write our function. Function is 2x squared minus 4x plus y squared minus 4y plus 1. Okay? So if you substitute 1, 2 in this function, you will obtain minus 5. If you substitute 0, 2, you will obtain minus 3. And if you substitute 0, 0, you will obtain 1. So as you can see, the absolute minimum value of the function is f of 1, 2, which is minus 5. And it occurs at the point 1, 2. And the absolute maximum value of the function is f of 0, 0, which is 1, and it occurs at the point 0, 0. Okay. So let's solve the next problem. And for this time, we are given a circular region, not rectangle, not triangle, but a circular region. Okay. So to find the absolute minimum and absolute maximum, again, I will follow the same steps. In the step 1, I will find the critical points. Okay, so function is here. So the first derivative of this function will be 2x minus 1 with respect to x. And the first derivative of this function with respect to y is directly 4y. Okay, if I equate them to 0, then from here I have x is 1 over 2, and from here I have y is 0. So 1 over 2, 0 is the critical point. But we should check whether or not it is in the given region. So to do this, I will substitute these numbers to here, and I will obtain 1 over 4, which is less than or equal to 1, so it is okay. 1 over 2, 0 is in the given region. So I will deal with this point at the next step, at the final step. Okay, so step 2, boundaries. But here we have only one boundary. Why? Because we have just a circle, a circular region. And here I have 1, here I have 1, because x squared plus y squared equals less than or equals 1 is that region. So the boundary is only x squared plus y squared is 1. Okay, so this is our boundary. So to analyze it, I will substitute the boundary in my function. Okay, I will first of all separate this y squared like that. Okay, so because this part is 1 on the boundary, I will write 1 plus y squared minus x here. Okay, why? Because x squared plus y squared is 1. And then I will replace y squared with the using this equation, I will write y squared in terms of x squared. So I have 1 plus 1 minus x squared minus x. Okay, at the end, I have this minus x squared minus x plus 2. Okay, and because we have a circular region here, as you can see, x changes between minus 1 and 1. Okay. If you look at the region, x is between minus 1 and 1. So at the end, I have such a function, g of x equals minus x squared minus x plus 2, and the interval is minus 1 and 1. So the prime, g prime of x is minus 2x minus 1 is 0. So I have x equals minus 1 over 2. Sorry, is there any mistake here? Okay. I have x equals minus 1 over 2. Okay. If x is minus 1 over 2, this is a critical point here. X equals minus 1 and x equals 1 are end points. Okay. So to find the point for our region, I will substitute x equals minus 1 over 2 in the function. Minus 1 over 2 squared plus y squared equals 1. So I have y squared equals 3 over 4, which means y is minus or plus in the square root 3 over 4. And here, if you substitute x is 1 or x is minus 1, you will obtain minus or plus 1 squared plus y squared is 1. So y squared is 0, so y is 0. Okay, so we have these points at the end. I have the following points. First of all, minus 1 over 2 minus square root of 3 over 2, minus 1 over 2 plus square root of 3 over 2, and minus 1 0 and 1 0. Okay, we have 4 points from the boundary, and I have here there are the points from the boundary, critical points and the end points, and I have one point in the region, a critical point in the region. So in the step 3, I will make a chart here. So in this chart, I will add all those points, okay? X, y, and my function is x squared plus 2y squared minus x. So first of all, I have obtained 1 over 2, 0 points. And then I have minus 1 over 2 minus square root of 3 over 2. Then minus 1 over 2 square root of 3 over 2. And minus 1, 0 and 1, 0. We have 5 different points. So at these points, my function takes the following values. If you substitute this point here, then you will obtain minus 1 over 4. F of minus 1 over 2 minus square root of 3 over 2 is 9 over 4. F of 1 over 2 minus 1 over 2 plus square root of 3 over 2 is 9 over 4. F of minus 1, 0 is 2, and f of 1, 0 is 0. So if you look at these values, you will see that the maximum value is here 9 over 4 and the minimum value is minus 1 over 4. Hence the absolute maximum value is f of, and this occurs at the point minus minus 1 over 2 minus plus square root of 3 over 2, which is 9 over 4, and the absolute minimum value is f of 1 over 2, 0, which is minus 1 over 4. The absolute maximum occurs on the boundary, but this occurs inside of the region. Okay, so this is the end of this video. See you on next video.